How do you prevent overfetching data from your API endpoints? Imagine you're at a buffet and you pile your plate high with food you don't really want. That's what overfetching data from an API is like, getting more information than you actually need. It might seem harmless, but it can slow things down, waste bandwidth, and put unnecessary stress on your server. So, how can you make sure your API only gives out what's necessary? One simple way is to use pagination. Think of it as serving your data in small, manageable portions. Instead of sending all the data at once, you ask for a specific number of items, like 25 orders at a time. You can specify where to start with an offset, so you can fetch the next set when needed. This keeps responses quick and light. Next, you can add filtering and sorting options. Imagine you only want to see shipped orders that cost more than $100. By allowing clients to specify filters like status or minimum cost, they only get relevant data. Sorting helps too, so they can see the newest or highest priced items first. This prevents unnecessary data from being sent over the network. Another handy trick is field selection, also called partial responses. Instead of sending every detail about a user, clients can choose just the fields they need. For example, they might only want the user's ID, name, and email. This reduces the size of the response and speeds things up. Some APIs do this with query parameters, while others use GraphQL, which lets clients specify exactly what they want in the query. GraphQL is especially useful because it exposes a single endpoint where clients define their data needs. They can request just the fields they want, avoiding overfetching by design. This makes data retrieval more efficient. You should also set limits on how much data clients can request at once. For example, if the maximum limit is 25 items, requests for 100 or 1,000 can be capped or rejected. Rate limiting is another good practice, limiting how many requests a client can make in a certain time frame to prevent abuse. On the back end, make sure your database queries are optimized. Instead of pulling entire records, fetch only the specific columns needed. Use projection techniques to select only the data you want, which makes database operations faster and less resource-intensive. Finally, responses can be compressed using tools like gzip, which reduces the size of data sent over the network. Caching frequent responses also helps, so the server doesn't have to generate the same data repeatedly. Combining these strategies creates an API that's quick, efficient, and easy to use. Clients get only what they need, and your server isn't overwhelmed. Whether you're building a REST API with pagination, filtering, and field selection, or using GraphQL to let clients specify their data, these methods keep your API lean and responsive. That way, everyone benefits from a smoother, faster experience.